Today we're going to be going through the 2019, 2018 Unit 1 paper for pure mathematics. All right, so let's get into it straight away. It says, let P and Q be two propositions. Complete the truth table. So very easy question. C-sec IT, not P, is just going to be false, false, true, true. That's not P. All right, not Q. We see Q, we have true, false, true, false. So this is going to be false, true, false, true. All right, no issues so far. All right, P or Q, it's only going to be true when either is true. So true or true is true. True or false is true. False or true is false. And false or false is false. So that's what we get. Now, not of P or Q is a negation of this. So it's going to be false, 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 true. Finally, they want what is not P and not Q. So false and false is false. False and false is false. False and true is false. True and false is false. And true is true. So that would be the truth table for this. Nice. Now it says, hence state whether these two are logically equivalent. So you can say, yes, according to the results from the truth table, according to the results from the truth table, you can tell them that the negation of P or Q, you can tell them that it is logically equivalent to the negation of P and it's logically equivalent to the negation of P and the negation of Q. So we're just telling them that, of course, these two statements are logically equivalent. Nice. Oh, I left out that and right here. So they are logically equivalent since they have the same truth results here. Nice. Second part of the question says, a binary operation defined by circle plus is defined on the set of real numbers such that a circle plus b is equal to 2a plus 3b. Find 5 circle plus 2. So 5 circle plus 2 means we're going to replace a with 5 and we're going to replace b with 2. So 5 circle plus 2 is equal to 2 times 5 plus 3 times 2. That is 10 plus 3 times 2 is 6. That is equal to 16. So 5 circle plus 2 is equal to 16. Nice and easy, soft. That takes care of question 1. Question 2 says, prove that circle plus is closed in R. So first we can tell them A is a real number, B is also a real number, right? And so that means that, what was it again? 3A plus 2B is also going to be a real number because the sum of two real number is closed under addition. So this is also a real number. But 3A plus 2B, that's just A star. This is just A star B. And so this implies that A star B is closed in R. Since A star B is equal to this, A star B is closed in R. Nice and easy. So it says this determine whether, oh, why am I saying star? It was circle plus. I'm changing the operator. My apologies, circle plus. Circle plus. All right. Now that we got that out the way, let's continue. Determine whether circle plus is commutative. So as we showed around here, we got 5 circle plus 2 is 16. So the easy way would to just be check if 2 circle plus is the same. So let's write it down. We got that 5 circle plus 2 is equal to 16. So let's check to see if 2 circle plus 5 is 16. So 2 circle plus 5 is going to be equal to 2 circle plus 5 is going to be 2 times A, so it's going to be 2 times 2 plus 3 times. Oh, it was 2A plus 3B, so that means up here it should have been 2A plus 3B. I wrote 3A plus 2B. This is 2A plus 3B, but it's still going to be a real number anyways. 2A plus 3B. So down here, 2 circle plus 5 is going to be equal to 2 times 2. 2 times 2 is 4 plus 3 times B. In this case, B is 5. 3 times 5 is 15. So 4 plus 15 is 19. And so circle plus is not commutative. Circle plus is not commutative. These two are not the same. They're not the same, so they're not commutative. All right. So the operator is not commutative. Nice and easy. So nice and easy. So we showed it's not commutative. Nice. Just check in 10, 16. Yes, that's fine. 2, 2 is 4, 15, 19. Good. All right, part C. Part C says given that 2x plus a times x minus 1 plus b times x plus 1 is equal to cx cubed minus 10x squared minus 2x minus 10. It says to determine the values of a, b, and c. There are 2 ways we can do this. We can set up an equation for a, b, and c using sums and products of roots. We could, because they have 3 equations here. Yeah, we could generate 4 equations and solve for a, b, and c. Or you could expand this left-hand side. So method 1 would be to expand this side. All right. So I'm going to do it method 2 first. Or method 1. Let's go method 1 first. I'm just itching to do it both ways. So let's look at method 1. Method 1 is the way where you expand this left-hand side. So 2x plus a times x minus 1 will give you 2x squared. 2x times minus 1 is minus 2x plus ax. So it's really plus. Instead of writing minus 2x and plus ax, just put plus a minus 2 bracket times x minus a. If you're wondering where this comes from, 2 times this is 2x squared, this times this is minus 2x, And this time this is ax. All I did was factor out the x. So that's that. Then you're going to multiply this by bx plus 1. Multiplying this by bx plus 1, it's going to be 2x squared times bx. That's 2bx cubed. And this time this is plus 2x squared. And this time this is going to be plus b times a is ba minus 2b. This is now ba minus 2b times x squared. Then we have 1 times, this is just going to be plus a minus 2 times x. Then you're going to have minus abx minus abx minus a minus abx minus a. And all of this is equal to your cx squared plus 10x, cx cubed plus 10x squared minus blah blah blah. So let me put it in a different color. Don't want to get it confused. So in the red is your left hand side. Then over here is your right hand side, which is cx cubed plus 10x squared minus your 2x minus 10. Now what you do then is you equate your x cubed term. So you equate your 2b, and 2b is going to equal to c. So equating x cubed terms, we're getting that 2b is equal to c. That's one equation. Then equating your x squared terms, as you can see, we have this as an x squared term and this as an x squared term. So what we're getting is your x squared term is really 2 plus ba minus 2b. That's equal to 10. That's what you're getting. That part is equal to 10. And so if you bring over the 2, you're getting ab minus 2b is equal to 8. That's what you're getting equating your x squared terms. Equating your x terms, what you're getting is a minus 2 times x minus abx is equal to minus 2. So equating your x terms, you're getting a minus 2 minus ab, and that is equal to negative 2. That's equal to negative 2. So if you want, you can bring over the minus 2 and add 2 to both sides. So really you're getting that a minus ab is equal to 0. That's what you're getting. All right. So these are the equations that we're finally reducing them down to. And then finally equating constants, we have minus a. Yeah, we have minus a is minus 10. And so from that, we're getting a equal 10. Now these questions get very easy once you find a. If a is 10, you plug 10 in here. And so that means 10 minus 10b. If a equal 10, that implies 10 minus 10b equals 0, and if 10 minus 10b equals 0, then therefore b equal 1. b is equal to 1. If b is equal to 1, we can check it here. 10 times 1 is 10. 10 minus 2 is 8, so good. Then we get c, because c is 2b. And so therefore c is equal to 2 times b, and so c is equal to 2. So in conclusion, we get a equal 10, b equal 1, a equal 10, b equal 1, and c equal 2. Log 4 of 2x minus log to base 2 of x plus 1 is equal to 1. The first thing we have to identify is that the bases are not the same. So let's convert the two of them to the same base. So I'm going to convert log to base 4 of 2x plus 1 to base 2. Let's convert both of them to base 2. Log to base 4 of 2x plus 2 is going to equal to log of the new base. So it's going to be log to base 4, log to base 2 now of 2x plus 2 over log to base 2 of 4. Log to base 2 of 4. But log to base 2 of the number, yeah man, so this works out to just be 2. So in the denominator, it's just 2. So now this, using this, we're going to solve this question now. So this becomes now log to base 2 of 2x plus 1, 2x plus 2, so it's log to base 2 of 2x plus 2 divided by 2. Alright, instead of saying divided by 2, better we put it like a half on the outside. So we can put a half on the outside here. Plus, or minus rather, log to base 2 of x plus 1. And this is equal to 1. Now we can then combine it as one logarithm. So I can bring up the half. Can bring up the half up here. Bringing up the half, it becomes square root. So writing it as one log, it's going to be log to base 2 of the square root of 2x plus 2. And that is being divided by x plus 1. And this is equal to 1. If this is equal to 1, what can we do? Well, the log of a base of a number is equal to a power such that the number, so this implies that the square root of 2x plus 2, square root of 2x plus 2 over x plus 1 is equal to the base to the power. So this is equal to 2. So we cross multiply now. We're getting that the square root of 2x plus 2, square root of 2x plus 2 is equal to, cross multiply, we get 2x plus 2. Wow. So the square root of 2x plus 2 is equal to 2x plus 2. Now, if you want, some persons might want to look at it like, if you wanted to call this a, let a be equal to the square root of 2x plus 2. Or maybe you want to call a 2x plus 2. So if a is equal to the square root of 2x plus 2, then you're solving a is equal to a squared. And carrying this over, then really and truly you're solving a squared minus a is equal to 0. And if a squared minus a is equal to 0, you factor out a, and you're getting a equals 0, or a minus 1 is equal to 0. But then what was a? A was the square root of 2x plus 2. So that implies that it's either the square root of 2x plus 2 is equal to 0. And if the square root of 2x plus 2 is equal to 0, then you square both sides. And from that, you're getting that 2x plus 2 is equal to 0. And so x is equal to negative 1. So you're getting x is equal to negative 1. Or if a minus 1 is equal to 0, then the other possibility is you're finding now the square root of 2x plus 2 is equal to 1. So when you square both sides, you're getting that 2x plus 2 is equal to 1. And if 2x plus 2 equal 1, then x must be equal to carry over 2 divided by 2, x equal minus a half. X is equal to minus a half. Now if x is equal to minus a half, let's check it. X can't equal negative 1. Let's just say that right away. If x is negative 1, you're getting a log of 0, and the log of 0 does not exist. So this one is not valid because we cannot work out the log of 0. So this one is not valid. So the final answer is just x equal minus a half. So the final answer is x is equal to negative 1 over 2. That's the final answer. And that completes question number 1. Nice. Moving right along. Question 2. Question 2 says the diagram below shows the graph of the function f of x. And this case says sketch the inverse of f of x. Sketch the inverse of this function. So let's do that. Sketch the inverse of this function. I like to do this first. I like to draw the line y equal x before I sketch the inverse. So I have the point 10, 10, pass through the origin. So this is just the line y equal x I'm putting in. That's just the line y equal x. And you might wonder, why do I need to do that? When I'm sketching inverse, I like to just put in the line y equal x. Next thing is that, look at this, 0, 0 is on this curve, so 0, 0 will on the inverse as well. There's a point 2, 4, 6, 8, 10, so this is 2. When x is 2, y is 5. So when you interchange them for the inverse, we need to plot the point 5, 2. So you have 2, 5, then the inverse will have 5, 2. So this is 2, 4. This will be 5. Wait, that's not 5. My apologies. Why am I giving such poor calculations? This is 2, 4, 6, 8. This is 8. This is 8. So 2, 8. And so if 2, 8 is right here, then the point on the curve is 8, 2 on the inverse. So this is 4, 6, 8, and this is 2. All right, so the curve is going to go like this. The inverse curve is going something like this on that side. Now let me see how it behaves down here. Now I have a point minus 2, 8, and so I need to go minus 8. I have a point minus 2, minus 8, so I need to go minus 8, minus 2. which is here. That's a point. And so that this inverse going like this, pass through that point. All right, and so this will be the inverse as f inverse of x. Nice and easy, very easy question, soft. All you had to do was just reflect this in the line y equal x. Just reflect the graph in the line y equal to x. Now it says use a graphical method to show f is bijective. So using a graphical method, the first thing to be bijective, it's 1-to-1. So we're going to do the horizontal line test to show that it is 1-to-1 first. So doing the horizontal line test, so right here, you can see using horizontal line test, f is 1-to-1. Clearly, using the horizontal line test, we can see that f is 1-to-1 right here. We do the horizontal line. This red line is the horizontal line test. Nice. So we do the horizontal line test. So f is 1-to-1. No need to show that it is surjective. No. Using the same horizontal line test, using the same horizontal line test, as you can see, stopping even down here, for all x, for all y, there is a corresponding x. And for all x, there's a corresponding y. All right, so using horizontal line test again, using line test, you can see that the codomain is equal to the range as all y values are mapped to. All right, and so the codomain is equal to the range. So using that method, we can say hence, since f is 1-to-1 and onto, hence f is bijective. Nice and easy, soft, a capital T. Now that we showed f is 1-to-1, we go to part B. Part B says prove that x minus y, the modulus of that, is less than or equal to the modulus of x minus z plus the modulus of x minus, modulus of z minus y. Now before we do this question, just want to write down that what the triangular inequality is. Going back to the triangular inequality, all right, well, let's do it this way then. All right, so the modulus of x minus y, modulus of x minus y, well, the modulus of x minus y is equal to the modulus of, we can write this as x minus y minus z plus z. Yeah, man, though we can do that. Definitely we can do that. We definitely can do that. Then this right here, we can break it up as, we can break up this now as, we're going to group the x with the minus z, x minus z. We're going to group that part together, plus we're going to group this part together now. All right. Then we're going to group this part together now. We're going to group this part together, which is now y or z minus y. Group those parts together. Nice. So we have that the modulus of this is equal to the modulus of this, which is good, which is good, which is good. Remember, modulus means length. Modulus means length. All right. And so what we have then in this case, we have that x minus y, the modulus of x minus y is equal to the modulus of this. So that implies, what does modulus mean? That implies that the modulus of x minus y, modulus of x minus y is equal to this square plus this square square rooted. That's equal to x minus z square. That's what modulus means, length, x minus z square plus z minus y square. All right, let me write this a little better. Z minus y bracket square, and all of this is being square rooted. That's what modulus means. So this is what we have. All right, so this is now the modulus of x minus y. Now look at this now. Now this now, the modulus of x minus z would just be x squared plus z squared square rooted. And this part, let's just work it out. We're gonna see. So the modulus of x minus y is working out to be the square root of, inside this bracket would be x squared. This would be x squared minus 2xz. And this would be plus z squared. This would be plus another z squared minus 2yz plus y squared. All right, so that is the modulus of x minus y. The modulus of x minus y. We're almost finished, don't worry. Modulus of x minus y is just working out to be the square root of x squared plus y squared, x squared plus y squared plus 2z squared minus 2x minus 2xz minus 2yz. That's the modulus of x minus y. And clearly, this is going to be less than, look at this now. Now, the modulus of x minus z, that's going to be equal to x squared plus z squared square rooted. This is x squared plus z squared square rooted, and the modulus of z minus y, modulus of z minus y is equal to the square root of z squared plus y squared. All right, clearly. All right, so what we're saying is clearly the sum of these two must be greater than this. It has to be, it has to be. Why does it has to be? This has some subtracting in. All right, this has some subtracting. This has to be. This is going to be greater than this. So what am I saying? I'm saying that the square root of x squared plus z squared plus x squared plus z squared plus the square root of z squared plus y squared, all of this is greater than or equal to the square root of, I can't write out all of that, so I'm just going to show that this is greater than the modulus of x minus y, where the modulus of x minus y was this, and so the modulus of this part was x minus z, so the modulus of x minus z plus the modulus of plus the modulus of x, modulus of x minus z plus the modulus of z minus y. This is definitely greater than or equal to the modulus of x minus y. That's the proof for it. Nice and easy, soft. Now what you could do is, you could even test it like right here. Let's say x, y, and z was 1. If x, y, and z was 1, right, just to test it, look at this. If x, y, and z is equal to 1, let's say all of them is 1. If x is equal to y, which is equal to z is equal to 1. Look at this. If all of them equal 1, in this case, you would get the modulus of x minus y to be 1 square plus 1, 1 plus 1 plus 2 times 1 is 4, minus 2, that's 0. In this case, it would be 0. In this case, you'd be getting that the mod of x minus y. In that case, it'd be getting that that's equal to 0. Now look at this now. X has 1, and x has 1, you get in 1 plus 1 is 2, so you're getting that. In this case, it'd be getting the square root of 4. In this case, you're getting it to work out to be 4. So that if x, y, and z is 1, down here, so you'd be getting the mod of x minus z plus the mod of z minus y. Using the formula, you'd be getting it to equal to the square root of 2 plus the square root of 2. You'd be getting square root 2 plus square root 2, which is 2 root 2. So clearly, as you can see, this is true. This was just an example. You wouldn't put an example in the proof. It's just to show you from calculation. Because this has the subtract right here, then definitely these two just being adding is always going to be bigger than this. Once some subtracting is taking place, then in here under the square root is just pure plus. Clearly this is going to be bigger than this. That's how you prove that. So these shouldn't have to be putting in it if that. That's the proof. Moving right along. Solve this inequality. So let's go ahead and solve this inequality. Solving this inequality. So what we do first is, moving right along, we're going to solve that inequality. So we have the mod of 6x plus 6x minus 2 plus x squared is less than or equal to 5. So first thing we need to do is subtract x squared from both sides. We get that 6x minus 2, the mod of it is going to be less than or equal to 5 minus x squared. And if that is true, then that means that 6x minus 2 is going to be between 5 minus x squared, and it is also between minus of 5 minus x squared, which is x squared minus 5. Now to solve this inequality, first thing I'm going to do is I'm going to consider this part first. So I'm going to consider the left-hand side of the inequality first. All right, so I'm going to consider the left-hand side first. Looking at the left-hand side of the inequality, I am solving 6x minus 2 is greater than or equal to x squared minus 5. So looking at that, I'm getting, bring over this and bring over this, I'm getting 0 is greater than or equal to x squared minus 6x. Adding 2 to both sides, I get minus 3. Can I factorize this? Let me see. 6 squared minus 4 times 1 times minus 3. Alright, so I can't factorize this, so I'll go to the quadratic formula. That's crazy. So I go to the quadratic formula to find what x would be. Going to the quadratic formula, x would be equal to minus b, which is 6, plus or minus b squared minus 4ac over 2a, which is the square root of 48 over 2. So I'm getting x would be the square root of 48. I think that is 48 can be broken up as 16 root 3, 60 root 16 times root 3, and the root of 16, I believe the root of 16 is 4. And then 4 over 2 is 2. So I would write this as 3 plus or minus 6. 4 over 2 is 2. So it's 3 plus or minus 2 root 2. So from this end, the solution for this would be that x is between 3 plus root 2 and x is between, from right here now, x is between 3 minus 2 root 2. I left off the 2 right here, 3 plus 2 root 2. So that's from the left-hand side of the solution. Going to the right-hand side now. Going to the right-hand side. Going to the right-hand side, I would be having that 6x minus 2 is less than or equal to x squared minus, the right-hand side was 5 minus x squared. So I have that x squared. This would be 5 minus x squared. Bringing it over, I have x squared. Was it 5 minus x squared? Let's go again, the right-hand side. 5 minus x here, 6x minus 2. So this would be 6x minus 2 is less than 5 minus x squared. Bringing over this, I would get x squared plus 6x minus 7 is less than or equal to 0. So what I would be getting is, if I were to factorize this one can factorize. It would be x, 7, and 1. Signs are different, the greater product positive, so this is plus, and this is minus, this is less than or equal to 0. And so to finish it off now, in this case, from this, so from the right-hand side, let me separate the solutions. So from the right-hand side, what I'm getting is x is between, this looks like 1 and minus 7. X is between 1 and minus 7. All right, so now what will be the final solution? So I'll put the final solution in black. The final solution will have to incorporate both of them. Final solution. Let's look at this. 3 minus 2 root 2. That's 0 point something, and 3 plus 2 root 2 is 5.83. So what will be the final solution? The final solution will be from the lower value, which will be from minus 7 less than or equal to x, and x will be less than or equal to 3 plus 2 root 2. So this is the answer. When you combine these two inequality, this is what you would get. I want to write it so it's a little more clear. X is between 3 plus 2 root 2 and it is greater than or equal to right here, which is minus 7. That's the final answer. Anytime you get an answer, you want to check it. So you check it by putting a number. This don't look like minus 7, look like 7. It should be minus 7. So this is the final answer. That's the answer. X is between 3 plus 2 root 2 and minus 7. When you get your answer, you want to check it. So you can put in a number like negative 6. Check it. 6 times negative 6 minus 2, that's 38 is the modulus. Then 5 minus negative 6 squared. So you can check it like over here. Let's see. Negative 6. Plugging in negative 6. Negative 6. Plugging in negative 6. And this up here, you get 6 times negative 6 minus 2. That's 38. Plus negative 6 squared. Well, negative 6 won't be right. Let's check it from negative 4. 6 times negative 4 minus 2 plus negative 4 squared. That's negative 6 times negative 4 square. 6 times negative 4 minus 2 is 26, and 26 plus negative 4 squared is 42. That's not giving me less than 5. So the minus 6 is not correct. Let's check this solution. All right, this is the good thing about modulus question. You have to check your solution. So as you can see, the minus 7 part is not working. So let's check from 3 minus 2 root 2. That is 0 point something. So let's check from 0. 0 minus 2 plus 0, that's good. And so indeed, the smaller part works. So 3 minus 2 root 2 works. So in this case, that's why it's good to check your answer. So what we're getting when we check, this is the final now when we check it. We're getting that X is greater than or equal to this part, 3 minus 2 root 2. When we check it, 3 minus 2 root 2. All right. And it's less than or equal to, let's check if 1 is good. When you put in X as 1, 6 times 1 minus 2 plus 1, yes. So 1 is fine. But it can extend up to 3 plus 2 root 2. So let's check if 3 plus 2 root 2 works. Let's check when X is 2. 6 times 2 minus 2 plus 2 squared. That don't work, so it's top of 1. So this is what happened. This is the final answer when you combine these two inequalities. So this one combined with this one gave the final answer to be that. So that's the final answer. We combine the two inequalities to get that. Nice and easy. 8 well-deserved marks. All right. Next part of the question, it says, given alpha, okay. Given that alpha and beta and gamma are the roots of the equation, it's too much. Go a little bit, yeah, that's better. Given alpha, beta, and gamma are the roots of this cubic equation, determine the equation whose roots are 1 over alpha square, 1 over beta square, 1 over gamma square. So first they give us a cubic. and these have roots alpha, beta, gamma. So the sum, which is alpha plus beta plus gamma, that is equal to minus b over a, is going to be equal to minus alpha plus beta plus gamma is minus 1 over 2. So the sum is 1 over 2. Then the product by 2, which is alpha times beta plus beta times plus beta times gamma, alpha times beta plus beta times gamma plus alpha plus alpha times gamma. The product by 2 is going to be equal to c over a, which is 0, because there is no x term. Then alpha, beta, gamma. Alpha, beta, gamma is equal to minus d over a. So it's going to be equal to minus 1 over 2. So it's minus d is minus 1 over a. All right, so now we have the sum. We have this, and we have the pairwise product. Now to find a new cubic equation, we need the sum of the new cubic. The sum of the new cubic, the sum is going to be equal to 1 over alpha square plus 1 over beta square plus 1 over gamma square. To work this out, we're going to have to find their LCM, and the LCM of this is going to be, common denominator is going to be alpha, beta, gamma, all square. And when you work this out, you're going to get this into this leaves alpha, this into this leaves beta gamma square. So this will leave beta gamma all square plus this into this will leave alpha gamma all square, and this into this will leave alpha beta all square. That will leave alpha beta all square. So what that works out to be now is, this works out to be equal to alpha beta. This is the formula that they give us for this now. Here's the formula. They tell us that it's equal to alpha beta, beta gamma plus gamma alpha all square. So it works out to be 0 square minus 2 alpha beta. Alpha beta is minus a half times minus 2. That works out to be plus 1 times alpha plus beta plus gamma. Alpha plus beta plus gamma is a half, so it works out to be 1 times a half. Now all of this is divided by alpha beta gamma square. Alpha times beta times gamma is, alpha times beta times gamma is minus a half. So it's minus a half square, which is a quarter. You just need to work out what's a half divided by a quarter. Half divided by a quarter, and that is 2. Half divided by a quarter is 2. So that's the sum of the new cubic equation. Now let's find the product, P2. So the pairwise product now is going to be 1 over alpha times beta square, 1 over alpha times beta square, plus 1 over alpha times gamma square, plus 1 over beta gamma square, beta gamma square. Nice. So again, we're going to use the LCM. And the LCM for this is going to be alpha, beta, gamma, all square. And what we're going to get when we work this out is this into this is now, it just leaves gamma square. This into this leaves plus beta square. And this into this leaves alpha square. So gamma square plus beta square plus alpha square. But what's gamma square plus beta square plus alpha square? Let's check it out. They give us a formula that gamma plus beta plus alpha square is alpha plus beta all square, and alpha plus beta plus gamma is a half, so it needs to be a half square. So it's going to be a half square. So it's a half square minus so it's a half square minus 2 times alpha gamma beta gamma. All right, minus 2 times 0. It's minus 2 times 0 over alpha beta gamma all square. Alpha beta gamma all square. Alpha beta gamma is minus a half. And so we have minus a half all square. Minus a half all square is a quarter. So we have a half square divided by a quarter. That will give us the product by 2. A half square divided by a quarter is 1. Nice. So now P3 is now going to be the product by 3. And the product by 3 is just going to be 1 over alpha beta gamma all square. And 1 over alpha beta gamma all square is just equal to 1 over alpha beta gamma is minus a half square, and 1 over minus a half square, I think that's 4, but I'll just check it out just to make sure. 1 divided by a half square, yes, it's 4. And so the new equation, so the new cubic equation, let's write it here. So the new CE, new cubic equation, will be given by x cubed minus the sum of the roots. The sum of the roots is 2, so it's x cubed minus 2x squared plus the product of the roots. Product of the roots is 1, so it is plus x minus the product by 3 of the roots, which is minus 4, and that's equal to 0. That's the new cubic equation. Nice and easy, soft. This takes care of module 1, module 2 time, onto module 3. Nice and easy. Number 4 is 2. Keep that in mind. So I'm just going to jot down right here. I know that sec 2 theta is 1 over cos 2 theta, and tan 2 theta is sine 2 theta over cos 2 theta. So in reality, I'm trying to end up with 1 plus sine 2 theta over cos. All right, this is sec 2 theta plus sine 2 theta. So this is my end result I'm trying to get to. 1 plus sine 2 theta over cos 2 theta. All right, so I noticed that I need to, this is what I'll be working towards. I'm working towards getting cos 2 theta in my denominator. So all of this should simplify to be cos 2 theta in the denominator. So let's get it. All right, so let's see how we can simplify this best. So typically we want to start with our left-hand side. Now we're going to substitute in the identity for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. That's sine 2 theta, 2 sine theta times the cosine of theta. And then we want to plug in the identity for cos 2 theta. Identity for cos 2 theta is, well, there's 3 identity, but I'm going to use 1 minus 2 sine square. You might wonder why. I'm using this one because I just want sine in the numerator to be dominant and cos in the denominator to be dominant, if that makes sense. So I'm going to use 1 minus 2 sine square. That's for cos 2 theta plus 1. So in the denominator now, what I'm going to have is cos 2 theta. Cos 2 theta is 2 cos square theta minus 1. As I said, I'm going to use this identity because I want sine to be dominant in the numerator and cos to be dominant in the denominator. So 2 cos square theta minus 1 plus sine 2 theta is 2 sine theta cos theta. Two sine theta cos theta. And then I have minus 1 right here. So I put like the minus 1. Now I'm going to simplify the numerator. So this is now equivalent to, now when I expand the numerator here, minus 1 plus 1 going to cancel, and minus 2 become plus. So in the numerator, what I'm going to be left with is 2 sine theta cos theta plus 2 sine square theta. I have now plus 2 sine square theta. No real issues. Nice. Plus 2 sine square theta. And then all of this is of course being divided by 2 cos square theta minus 1 plus 2 sine theta cos theta minus 1. No, all of this is just minus 1 and minus 1 make it become minus 2 here. Right? And so this is just 2 cos square theta. This is 2 cos square theta plus 2 sine theta cos theta minus 2. So what I'm going to do now is I'm just going to, I notice that there's so many 2's. I notice there's a 2 here, a 2 here, a 2 here, a 2 here, and a 2 here. So I'm just going to divide through the expression by 2. I'm going to divide through the expression by 2. I'm going to divide the numerator and the denominator by 2. I don't like seeing so many 2's. So I'm going to divide both the numerator and the denominator by 2. Just going to get rid of those 2. Getting rid of the 2's, numerator is going to just leave me back with sine theta cos theta plus sine square theta. That's what I'm left with, sine theta cos theta plus sine square theta. Then in the denominator now, what I'm going to do is, I divide through by 2 as well. So now I just have cos square theta plus sine theta cos theta. Now remember my objective. My objective is to generate this denominator. So I need to figure out how am I going to generate that denominator from this position. Now, one thing I notice is that I see a minus 1 here. But I know that 1 is sine squared theta plus cos squared theta. So I'm going to replace 1 with sine squared theta over cos squared theta so that everything is in terms of sine and cos. So this becomes equivalent to, in the numerator, I'm going to factor out sine theta. So I factor out sine theta from the numerator. And what I'm left back with is cos theta plus sine theta. And then in the denominator, as I said, I'm going to change 1 to sine square theta plus cos square theta. So in the denominator, it's going to become cos square theta plus sine theta cos theta. And then that 1, when I change the 1 to sine square plus cos square, it's going to just become minus sine square minus cos square. Minus sine square theta minus cos square theta. Because it's minus 1 in it. It's really minus 1, so it's minus cos square. Alright. Now let's see what we have now. Now we have cos square. We have cos square and minus cos square. Cos square and minus cos square, these two cancel each other. Cos square theta cancels minus cos square theta. Good. So we're just left back with these two. So we're nice now. We're almost done. So what we end up getting now is, this is now equivalent to sine theta into cos theta. Sine theta into cos theta plus sine theta. And this is now being divided by, going back around here, as you can see, we have now sine theta cos theta minus sine square. Both of these two have sine theta in common. So I'm going to factor out a sine theta. I'm going to factor out a sine theta. So while I factor out a sine theta, let me see what's going to happen. When I factor out sine theta, I'm going to be left back with, going around here, going to be cos theta minus sine theta. So I'm left back with cos theta minus sine theta. Alright, and so the sine theta is going to cancel the sine theta. And so this is what we're left with. Now you might say, so sir, how are we going to generate cos square? Good. Now remember, cos square is cos 2 theta. This is what we want to get in the denominator. We want to get cos 2 theta. But cos 2 theta is equal to cos square theta minus sine square theta. So what we're going to do to get that now is we're going to multiply this now by the conjugate of the denominator, which is cos theta plus sine theta. So we're going to multiply by cos theta plus sine theta. We're going to multiply the numerator and the denominator by cos theta plus sine theta. When you multiply the numerator by cos theta plus sine theta, you notice that it's going to be a square in the numerator and the difference of 2 square in the denominator. So it's a perfect square in the numerator. So it's going to become cos theta times cos theta is cos square theta. And then you're going to have cos theta times sine theta is sine theta cos theta. Sine theta times cos theta is sine theta cos theta. So that is just plus 2 sine theta cos theta. And then you're going to have sine theta times sine theta, which is sine square theta. Good. And then in the denominator, it becomes the difference of 2 square. Cos theta minus sine theta times cos theta plus sine theta. That's the difference of 2 square, so it becomes cos square theta minus sine square theta. So now we're good. Now what we notice is that cos square plus sine square is equal to 1. That becomes equal to 1. Then sine 2 theta is 2 sine theta, cos theta is sine 2 theta. And cos square minus sine square is cos 2 theta. So done. because we can then just separate this now as two separate fractions as 1 over cos 2 theta when we sec 2 theta plus sine 2 theta over cos 2 theta. And we're done now. We've pretty much finished. So that's 8 marks, nice and easy. As 1 over cos 2 theta, you can tell them that now is sec. And then sine 2 theta over cos 2 theta is tan. And so finally we complete the proof. Tan 2 theta. That's your right hand side. Nice and easy, soft. That's your right hand side. Nice. So we completed the proof now. We have it, that's the proof. All right. We may continue. It says hence meaning using this result right here, we can solve that result equal to 0. So I'm going to go with hence. So going with hence, I'm going to be using this result that I got, sec 2 theta plus tan 2 theta equals 0. And instead of saying sec 2 theta plus tan 2 theta equals 0, I'm just going to go to this one. 1 plus sine 2 theta over cos 2 theta equals 0. So hence, that implies, because it says hence, it implies that we can solve 1 plus sine 2 theta over cos 2 theta is equal to 0. And if something is equal to 0, then I count the denominator 0. I must the numerator 0. So that implies that we're solving the numerator 1 plus sine 2 theta. It must be that part being 0. And if this is what we're solving being equal to 0, then all we need to do is bring over the 1. So we're solving sine 2 theta equal to negative 1. So if you're solving sine 2 theta equal negative 1, next thing to do is draw your circle. Just get out your little circle. It's always good to put the circle there. And then you need to look at which quadrant is sine 2 theta negative. I know that sine is positive in the first and the second quadrant. So these are not what we want this time. We want where it's negative. It's negative in the third and the fourth quadrant. Now, first thing is find the principal acute angle in the first quadrant, which is sine inverse of 1. Sine inverse of 1 is 90 pi by 2. That's the angle in the first quadrant. So the angle in the third quadrant is going to be pi plus pi by 2. Pi plus pi by 2. And the angle in the third quadrant is going to be 2 pi minus pi by 2. Those are the angles in the quadrants, 2 pi minus pi by 2. They didn't give me degrees or radians, and so I'm going to stick to radians. Pi plus pi by 2 is 3 pi by 2. And 2 pi minus pi by 2 is, that is, the multiply of this, that's what? Multiply up to, I'm getting 4 pi, still 3 pi by 2. So the same angle is in the third and the fourth quadrant. So the general solution, is going to be equal to 3 pi by 2 plus 2n pi, where n is the amount of time you go around the circle. So that's the general solution. Nice and easy, soft. Easy 5 marks. Moving right along. It says, given that the cosine of A is equal to 3 over 5, and the sine of B is 3 over 4, calculate sine 2A. Now, I always like to just picture a little triangle. So you have the angle A, and they tell us that 3 over 5 is cos A, and so the adjacent is 3, the hypotenuse is 5, and so this is a 3, 4, 5 triangle, and so the opposite must be 4. Then sine B, meaning you have another triangle like this, and the angle is B, and they tell us that the opposite is 3, the hypotenuse is 4, so the adjacent is going to be, using Pythagoras theorem, it is 4 square minus 3 square all square rooted. 4 square minus 3 square rooted. Let me write that a little better. So 4 square minus 3 square all square rooted. So the adjacent is going to be 16 minus 9. That's 7. So the adjacent is the square root of 7. So what's sine 2A? Sine 2A, we have to remember, sine 2A is equal to 2 sine A cos A. That's the easiest formula to remember. Sine 2A is 2 sine A times the cosine of A. And so sine 2A works out to be 2 times what is sine A? Sine A would be opposite 4 over 5. So sine A is 4 over 5 times the cosine of A, and the cosine of A is 3 over 5. Nice and easy, soft. So you go ahead and you work these out now. So 2 times 4 is 8. 8 times 3, 8 times 3, 24. So sine 2A is 24 over 25. No issues with this question. 24 over 25. Nice. Now here, you're asking us what is cos A plus B. Cos A plus B, we have to remember that this is the compound angle formula. Cos A plus B is cos A cos B minus sine A sine B. Once you remember this formula, cos A cos B minus sine A sine B, we're good to go. Cos A cos B minus sine A sine B. So that's going to be equal to cos A cos B. Cos A is 3 over 5. Cos B is cos B. From this triangle, cos B will be adjacent over hypotenuse, which is adjacent is root 7 over 4. So cos A, 3 over 5. Cos B, root 7 over 4. Minus sine A sine B. Sine A will go over to this triangle again. Sine A is opposite over hypotenuse, which is 4 over 5. Minus sine B. What is sine B? Sine B is, we'll go over to this triangle. Sine B is opposite over hypotenuse, which is 3 over 4. You may proceed to simplify your answer now. This is 3 root 7 over 20. I'm just going to write it as one fraction. 3 root 7. 3 root 7. 4 times 3 is 12. So 3 root 7 minus 12 over 20. That's 3 root 7 minus 12 over 20. Nice and easy, soft. Okay, so we finished that question. Now finally, this part of the question says, solve the equation sine theta. Is that a minus? Let's look. Yeah, that's minus. Solve the question sine theta minus root 3 cos theta equal 1. Once you're given these trig equations, the first thing to do is divide through by either sine or cos. I'm going to divide through by cos theta. If I divide through by cos theta, then sine theta over cos theta gives me tan theta. Let me see, tan theta. All right, let's not do it this way. I'm not going to do it this way. All right, first thing I'm going to do is I'm going to rewrite it in the r cos form. When it's equal to 0, it's easier to do that. I'm going to write it in the r cos form. In the r cos form, r would be equal to 1 square plus root 3 square, which is just 3 all square rooted. And so r is equal to, it just feels easier for me. Of course, you may have solved it differently. This is 2. Then I find my alpha. Alpha is tan inverse b over a. And so it's going to be tan inverse of minus root 3. Tan inverse of minus root 3. We work that out and we're getting, put that in a calculator, tan inverse of minus root 3. I'm getting minus pi by 3. And so to put it in the r sine form, I can rewrite this side as 2 times the sine of theta is 2 times the sine of theta minus alpha, and alpha is minus pi by 3, so it's going to become minus and minus become plus. So it's theta plus pi by 3, and that's equal to 1. So then I divide through by 2 to get that the sine. I get the sine of theta plus pi by 3 is equal to 1 divided by 2. And 1 divided by 2 is a half. So now this is what I'm solving. I'm solving the sine of theta plus pi by 3 equal to a half. As I always say, the next thing to do is draw your circle. You need where cos is positive. So you draw a little circle somewhere. You want where cos is positive. You cut your circle in 4 little quadrants. And cos sine is positive in the first and in the second quadrant. And so now you take sine inverse of a half. Sine inverse of a half will give you the angle in the first quadrant. So sine inverse of a half to find your principal acute angle, and that is pi by 6. You're going to get pi by 6. So the angle in the second quadrant is going to be pi minus pi by 6. And so that is what's going to give you your possible solutions for this. So that implies that theta plus pi by 3 is equal to pi by 6. Theta plus pi by 3 is equal to pi by 6. That's one possibility. This should have been pi by 3. So theta plus pi by 3 is equal to pi by 6. That's one possibility. Or the other possibility is that theta plus pi by 3 is equal to pi minus pi by 6. And pi minus pi by 6, this part simplifies to be 5 pi by 6. 5 pi divided by 6. That's what we're getting. Nice. So moving right along. So all we need to do now is subtract pi by 3 from both sides. And so we're going to get theta is equal to pi by 6 minus pi by 3. That is going to be pi by 6 minus pi by 3. All right, let me work that out in my calculator. Pi by 6 divided by pi by 3. Pi by 6 minus pi by 3. Pi by 6 minus pi by 3. And I get minus pi by 6. Minus pi by 6. So that's one possible answer for theta, minus pi by 6. Or the next answer is 5 pi by 6 minus pi by 3. So 5 pi by 6 minus pi by 3. And I get pi by 2. This one is giving me pi by 2. So theta equal minus pi by 6, or theta equal pi by 2. Those are the answers. If you don't believe it, you can check it out. Check it. Pi by 2 is 90 degrees. So put in a calculator sine 90 minus root 3 times the cos of 90. The cos of 90 is 0. So it's 1 minus 0, which is 0. 1 minus 0, which is 1, sorry. And you can check the other one as well, which is minus pi by 6. I guarantee you get it. Okay, you're going to get a half minus something. That's going to work out to be a half here. Then the half plus the half give you 1. So good. Question 4. So question 3 is usually fully trigonometry. And then question 4 is going to be a mix of like coordinate geometry and locus and stuff like that. Okay, question 4 says the equation of the circle and the straight line are given by x squared plus y squared minus 2x plus 2y plus 1 equals 0, and y is equal to x minus 3. Find the center and the radius of the circle. The shortcut method is to divide this part by negative 2 to find the center. Divide through by negative 2 to find the center. That's the shortcut method. So the center is 1 minus 2. But we don't take shortcut over here. Shortcut draw blood. So what we're going to do is complete the square. Completing the square of the x terms, we're going to get x minus 1 square. And then we subtract back 1 square. Completing the square of the y terms, we're going to get y squared plus 2y, so you half it. So you're getting y plus 1 square, and you subtract back 1 plus 1, and that's equal to 0. Then you put it in its standard form now, so you're going to get x minus 1 square, x minus 1 square plus y plus 1 square. And that's going to be equal to minus 1. Minus 1 is minus 2. Minus 2 plus 1 is minus 1. So when you bring it over, that's equal to 1. And you can always write 1 as 1 square. And so the center is 1 minus 1. And the radius is 1. So the radius is equal to 1. Nice and easy, 3 marks. Now it says show that 1 minus 2 is one of the points of intersection with this line. Now to show that it is a point of intersection, you don't need to solve this equation. What you need to do is, if 1 minus 2 is a point of intersection, of the circle and the straight line, then that means it satisfies both the equation of the circle and the straight line. So to show it is a point of intersection, we can show that the point satisfies both the equation of the circle and the line. So without doing too much work, let's do that. So that means this point is 1, x is 1, and y is minus 2. So we're gonna let x be equal to minus 1 and y be equal to, x equal 1, sorry. Let x equal 1 and y equal to negative 2, and we're gonna sub into the circle. Plugging it into the circle, we're gonna get 1 minus 1 square plus, when y is minus 2, you get minus 2 plus 1 square. And when you check that, you realize that you get 1 minus 1 square is 0. And then minus 2 plus 1 square is plus 1. And 0 plus 1 equal 1. So hence, we can see that 1 minus 2 lies on the circle. 1 minus 2 lies on the circle. Let's sub it into the line now. Now, sub x equal 1 and y equal 2 into the line. So substitute it into the line now. This is minus 2. Sub it into the line. And so what we're going to get when we sub it in the line is minus 2 is equal to 1 minus 3. No, that is correct. Yes, it is true. And so we can see that 1 minus 2 lies also on the line. Hence, the line and the circle intersect at this point. All right, so no whole heap of calculation. We didn't need to solve the equation simultaneously. All right, waste of energy. All right, see, 6 marks to do that, and we didn't need to solve it simultaneously. So hence but let's look at method 2. Method 2 is if you're bored and you wanted to solve it. Method 2. Method 2 is just the typical calculation method, substitute into the line, into the curve. So you have, I'm going to use this equation, this one, the general form. You have x squared plus y squared minus 2x plus 2y plus 1 equals 0. Let's looking at method 2, x squared plus y squared minus 2x plus 2y plus 1 is equal to 0. Was that it? I think this was the right equation. Let's check back. Yep, we write it correct. And y is equal to x minus 3. So you substitute y equal x minus 3 in here. And so you're going to get x squared. Substituting y as x minus 3, this will become plus first term square, which is x squared, minus twice the product of 2 minus 6x, plus second term square, which is going to be plus 9 minus 2x, and then 2 times y will be 2x minus 6, so it will be plus 2x minus 6. Then you have plus 1. And that's equal to 0. So what we did was substitute the line into the curve. Let's simplify this equation. X squared plus x squared is 2x squared. Then minus 6x minus 2x is minus 8x plus 2x, that's minus 6x. All right, that's minus 6x. And then we have 9 minus 6 is 3, and 3 plus 1 is 4. This is equal to 0. And then we divide through by 2 to solve a regular quadratic. So we get x squared minus 3x plus 2 is equal to 0. And then you could factorize it. Equals 0. You're going to have x, 2, and 1. Signs are the same, but both of them negative, so you have minus and minus. So in this case, you're getting x equal 1, or in this case, you're getting x equal 2. You're getting x equal 1, or x is equal to 2. So you plug x equal 1 into y here, and so you're getting y is equal to, plug in x equal 1, 1 minus 3 is minus 2. And you plug x equal 2 in here, and you get 2 minus 3 is 2 minus 3, 2 minus 3 minus 1. So those are the points of intersection. So finally, you can conclude points of intersection are 1 minus 2 and 2 minus 1. And hence, 1 minus 2 is a point. 1 minus 2 is a point. Hence, 1 minus 2 shown. Hence, 1 minus 2 shown to be a intersecting point. All right, so that's how you do that with method 2. But I prefer method 1. Look at method 1, it's so easy. You just substitute this into the circle, substitute it into the line. It's going to satisfy both equations, and so it must be a point of intersection. All right, this says determine the equation of the tangent to the circle at 1 minus 2. Now, before I even do this, I just love to get a sketch of the circle. I always draw my sketch of the circle. And the reason why I do it is it gives me a rough estimate of what the equation of the tangent should be, even before I solve it. So the center of the circle is 1 minus 1, 1 minus 1, all right, this is not coming out so pretty. Just having a little glitch. So the center right here is 1 minus 1. That's the center of the circle. Center is 1 minus 1 right here. And then the point 1 minus 2, if this is 1, minus 2 is directly below it. So what do you think is going to happen? 1 minus 2 is directly below it, so the tangent must be like this. So we can clearly see that the gradient of the tangent is going to be 0. So the equation of the tangent is going to be y equals something. That's why I love my sketches. My sketches can just show me already So this is clearly going, the equation of the tangent, even without solving it, I can tell that the equation of the tangent is y equal -2. That's the equation of the tangent. Without even solving it, the equation of the tangent is y equal -2. I can tell you that just by sketching it. All right, but let's do it by calculation. First thing we're going to do is find the gradient of the normal. The gradient of the normal is going to be rise. It has a rise, so it go -2 minus -1, -2 minus -1 over x2, which is 1, minus 1. And so the gradient of the normal is undefined, or as we would say, infinity. But if the gradient of the normal is infinity, then the gradient of the tangent is -1 over infinity, and -1 over infinity is 0. The gradient of the tangent is 0. If the gradient of the tangent is 0, then the equation of the tangent is y minus the y value. So it's y minus -2, which is y plus 2, is equal to the gradient of the tangent, 0, into x minus 1. And so what you're going to get now is 0 times anything is 0, and so y is equal to -2. But just by sketching the circle, you could see what is going on. So it's very imperative that we sketch the circle always. Nice. All right, part B. Part B says let U be S3, S, and V be -2, 6, and 4. And it goes further to say, show that U and V are not parallel. So to show that U and V are not parallel, let me see. Show that U and V are not parallel. There are many ways we can show that they're not parallel. That's a lot of marks, 9 marks they want to show, but I can already tell they're not parallel just by looking at them. Because look at this, if they're parallel, going back to CSEC mathematics, going back to CSEC maths, I'm going to write it down. If two vectors are parallel, then one is a multiple of the next. If two vectors are parallel, then one is a multiple of the next. That's what we know. If two vectors are parallel, then one is a multiple of the next. So let's show that. Look at this now. And so that means that maybe vector V is equal to some constant times vector U. All right, that's what we know. So vector V, which is -2, 6, 4, that is equal to some constant K times vector U. But what is vector U? Vector U is S3, S. All right. So what that means then is -2 is equal to K times S. -2 is equal to K times S. We're getting that 6 is equal to 3 times K. And if 6 is equal to 3 times K, then what we're getting then is K is equal to 2. So from this, we're getting K equal 2. And finally, we're getting 4 is equal to K times S. Now, if 4 is equal to K times S, right, then over here, if K is 2, then that means that 4 is equal to 2 times 2S and 2 times 2S. So in this case, S is equal to 2, right? S is equal to 2. So if K is equal to 2 and S is equal to 2, let's plug it in here. So in the last one, we're going to do a check now. But look over here. Over here, if you plug in now, check in the first one. So we're going to check in the I component. We're going to check in I. So if you check in the I component, what you're going to notice is that if you plug in K as 2 and S as 2, you're getting minus 2 is equal to 2 times 2. But 2 times 2 is not minus 2. So this is false. This is not true. This is false. So this is false. So this is false. And so they cannot be a multiple of each other, and so hence they are not parallel. That's the easiest way to prove that they are not parallel. Nice and easy, soft. Of course, some persons would have mentioned if they're parallel, then we know that their dot product is going to be equal to the product of their modulus. You can show that u dot v should be equal to the modulus of u times the modulus of v for some particular values of s. But you're going to work out and see that for no value of s will the two modulus be equal. Stuff like that. So you could do that as well as an alternate proof, but I'm going to stick with this easy one. All right, so clearly they're not parallel. Soft. All right, it says now, determine the vector equation of a plane which passes through the point 1, 3, 0 and which is perpendicular to that vector. Again, I always like to draw to see what's happening. I have a plane, and they said that the plane has the point 1, 3, 0. So maybe this is the point. I'm going to label it as A. So maybe this is the point A. I'm just labeling it. This is the point A. And they said that it's perpendicular to this vector. I'm going to call this vector. I'm going to call this vector N. Right, calling that vector N. You're going to see why soon. So if that vector N is perpendicular to the plane, then N acts as a normal to the plane. And so what that means then is R dot N is equal to A dot N, where N is the normal to the plane. And so the equation is going to be R dot N. N is 2, 4, 5. So it's R dot 2, 4, 5. That is equal to A dot N. And A dot N will be 1, 3, 0 dot N. And N is going to be 2, 1, 2, 4, 5. 2, 4, 5. So we work out this dot product now. 1 dot, that's now 2 plus, let me see, 1 times 2 is 2 plus 3 times 4 is 12. 12 plus 2 is 14. That's 14. R dot N is really 2x. This is 2x plus 4y plus 5z equal 14. But they didn't want this. This is a Cartesian equation. So always pay attention to what they ask. They ask for the vector equation. All right, they ask for the vector equation. So we're not going to write it in this form. This is the Cartesian equation. Cartesian equation. They want it in the vector equation. So the vector equation form, best way to leave it as is just the R dot Some persons like to leave it as the column vector. You can leave it as r dot 2, 4, 5 is equal to 14. That's one vector equation. Or some people like to leave it as this. They are both still vector equation. R dot 2i plus 4j plus 5k, r dot 2i plus 4j plus 5k equal 14. Either way you leave it is fine, because some people prefer the column vector form, some people prefer the ijk form. So leave it as any one of these, and these are the vector equations. All right, so anyway, it's up to you. All right, typically they usually ask to leave it in a Cartesian, but this time they said vector equation. This completes question 4. All right, so we reach question 5, which is module 3. Module 3. Module 3 constitutes of differentiation, integration, limits, and continuity. So looking at module 3, this question says use the substitution u as this to integrate this right here. So using that substitution, we're substituting u as x to the 4 plus 2, that is u. So if that is u, then you need to find du. Then du is going to be equal to carry down the power, which is 4x cubed dx. So of course, I'm going to call this integral I. I love to call them I. And so I is equal to, now look what I'm going to do. I'm going to write I as the integral of, instead of saying 4x to the 7, I'm going to break up 4x to the 7 as 4x cubed times x to the 4. Yeah, man. So I'm going to rewrite it as x to the 4 plus 2 all cube. And then, as I said, instead of writing 4x to the 7, I'm going to write it as times x to the 4, putting x to the 4 first, times 4x cubed dx. I might say, sir, why put it in that order? I put it in this order so I can use my substitution. X to the 4 times 4x cubed is still going to give me 4x to the 7. All right, now once you get to this stage, you're good, because guess what? You see right here, 4x cubed times x to the 4. These two right here, look at that. 4 plus 3 is 7, so this is still 4x to the 7. But this part right here, this 4x cubed dx, this part is du, this part is u cubed, x to the 4 now. Now if x to the 4 plus 2 is u, then x to the 4 by itself is just u minus 2. That implies that u minus 2 equal x to the 4. Yeah, man. So no good now, let us substitute. You'll see it better when we substitute. So I is working out clearly to be the integral of x to the 4 plus 2 cube, which is going to be u cube times x to the 4. X to the 4 is u minus 2. U minus 2. And then 4x cubed dx is du. That is du. Nice and easy. So we can go ahead and finish this. We're going to have u to the u cubed times u is u to the 4. Then u cubed times 2 is minus 2u cubed du. So all I know is add 1 to the power to get u to the 5th, divide by the power of 5, minus add 1 to the power to get 2u to the 4, divide by the power of 4, plus some constant c. Nice and easy, soft. So now that we have that now, we can resubstitute back for u. So resubstitute back what was u? U was, what is u again? U is x to the 4 plus 2. All of this just work out to be x to the 4 plus 2 raised to the 5th power. And instead of saying divide by 5, I'm going to put 1 over 5 on the outside. So it's 1/5 of this minus 2 over 4 is really a half. So it's minus a half times u to the 4 is just x to the 4 plus 2 raised to the 4th power. X to the 4 plus 2 raised to the 4th power plus some constant c. Nice and easy, soft. That is this question. Nice. All right, now this question says calculate the area of the region lying between the parabolas y equal x squared and x equal 1 over 8y squared. To calculate the area between these two, we are going to have to find the point of intersection. And first thing is, if I cross multiply this equation, it's really saying 8x is equal to y squared. All right, so cross multiply 8x is equal to y squared. Now y is equal to x squared. So if y is x squared, then I can substitute for y as x squared. So what that is telling me then is 8x is equal to, substitute for y squared as x squared, so I get x squared squared is x to the 4. So 8x equal x to the 4. I carry that over to get x to the 4 minus 8x. And that's equal to 0. And so one possible answer will be x equals 0. That's one answer, comma. Now the next answer I'm going to get is x cubed minus 8 is equal to 0. Now this is clear what x is. X equal 2. 2 cubed minus 8 is 0, so x equal 2. Clearly x must be 2. So the point of intersection are x equals 0 and x equal 2. You don't need to find the y point of intersection. You don't need to. Because when we're integrating to find area, the integral a, area, is going to be equal to the integral from x1 to x2, or you can say from a to b, of the first curve y1 minus the next curve y2. So you're going to put the two curves in together, dx. All right, that's all. Now let's go ahead and do that, but first thing, we need to make y the subject of both of them. Now in this one, y squared is 8x, so you can clearly see that then y would be equal to the square root of 8x. So in this case, the area is going to be equal to the integral from 0 to x being 2 of y1, we can call y1 x squared, minus y2, we can call y2 8x to the half power. This is 8x raised to the half power all right, dx. So let's go ahead and do this integration. Doing this integration, we add 1 to the power to get x cubed, divide by the power of 3, minus, we add 1 to the power to get 8x half plus 1. A half plus 1 is 3 over 2. Then we're going to divide it by 3 over 2. And also divide it by the differential in the bracket, which is 8. So divide it by 8 times 3 over 2. And we have to bear in mind that we're integrating from 0 to 2. Now in reality, we don't ever need to plug in 0 in these sort of circumstance. You just need to plug in the 2 rather. So when you plug in 2, you're going to get 2 cubed over 3, which is 8 over 3, minus, when you plug in 2 here, 8 times 2 is 16. So we have 16 times 16 raised to the 3 over 2, which is 64, divided by 8 times 3 over 2. And I'm getting 16 over 3. And so 8 over 3 minus 16 over 3 is minus 8 over 3. But as you know, area is positive, and so the area is just 8 over 3. All right, and so the area is 8 over 3. Even though I get minus here, the area is positive. So the area is 8 over 3 units squared. Now the only reason why I get minus, this just means that it should have been the other way around. I integrated the one that is below as above and the one that is above as below. That's all that means. So it is positive 8 over 3 units squared. That's the area. All right, so finish up integration, and now we reach differentiation. It says the equation of a curve, it's a quartic expression. F of x is 3x to the 4 minus 2x cubed minus 6x squared plus 6x. Find f prime of x. Now f prime of x just means that we're finding the first derivative. We carry down the power to get 12x cubed. Carry down the power, 12x cubed minus, carry down the power, we get 6x squared. Carry down this power again, we get minus 12x. And then differentiate 6x, we get plus 6. So that's the first derivative. Right here it says determine the second derivative. The second derivative is f double prime of x. F double prime of x is going to be equal to, when you differentiate 12x cubed, you're going to get 36x squared. Then you differentiate minus 6x squared, you get minus 12x. Then you differentiate minus 12x, you get minus 12. Nice. All right, let's see. 36x squared minus 12x minus 12. Good. So we find the first and second derivative. Nice. It says calculate the x coordinates of the stationary points. So you have to remember stationary points occur when f prime of x, or some people would say dy by dx equals 0. So it occurs when f prime, please look at this, see that it is f prime of x. F prime of x we found is 12x cubed minus 6x squared. Let's write it down. So we're going to be solving 12x cubed minus 6x squared, 12x cubed minus 6x squared minus 12x, 12x cubed minus 6x squared minus 12x plus 6. And we're solving that equals 0. So what we do is divide through by 6. And dividing through by 6, we're getting 2x cubed getting 2x cubed minus divide through by 6, we're getting x squared. Dividing through by 2, we get minus 2x. Dividing through again, we get plus 1. And this is equal to 0. If you're wondering what I did, all I did was divide through the expression by 6. So we're going to solve this cubic equation. To solve this cubic equation, we can use trial and error to find the root. So we're going to use trial and error. So we're going to try x equal to, let's say 1. 2 minus 1 minus 2 plus 1 is 0. So 1 works. So try x equal to 1. Trying x equal to 1, it works. And so 1 is a root. So 1 is a root. Now, if 1 is a root, then you could want to use factor and remainder theorem to solve it. But I'm tired of using factor and remainder theorem, so I'm going to use sums and products of roots. Now, the sum of the root from this equation, the sum is minus b over a. So minus b is a half. This works out to be a half. The sum of the roots is minus b over a, and the 3 roots are 1, and then the next 2 roots, I'm going to call them a and b. So 1 is equal to a plus b. All right. And then the product of the 3 roots is going to be minus d over a, which is minus a half. And minus a half is equal to 1 times a times b, which is ab. Good. So what I'm getting then is from this equation right here, all right, from this equation, these 2 equations, I'm going to solve them simultaneously. Solving them simultaneously, what I'm going to get is from the first equation, I'm going to carry over the 1, and so I'm getting a plus b is equal to a half minus 1 is minus a half. Then I'm going to multiply through by 2. Multiply through by 2, I get 2a. Yeah, 2a plus 2b is equal to minus 1. That's what I'm getting from the first equation. And from the second equation, I can divide through by a. So I'm getting that b is equal to, if I divide through by a, I get minus 1 over 2a. So these are the 2 equations I have now. I have 2a plus 2b equal to minus 1. I have b is equal to minus 1 over 2a. So I'm going to plug this equation in this equation. So doing that now, I'm going to get 2a plus 2b. 2b will now become minus 2 over 2a. And that's equal to negative 1. And so I multiply through by 2a. And so this will become 4a squared. 4a squared. Minus 1 times 2a, when I bring it over, it will become plus 2a. If you're wondering where I get the plus 2a from, the minus 1 times 2a is minus 2a, and I bring it over to this side. Minus 2 is equal to 0. I can then divide through by 2 to get Let me just finish it off right here. If I divide through by 2, I get that 2a squared plus 2a squared plus a minus 1 is equal to 0. Now I can factorize. Or if you can't bother factorize, just use quadratic formula. So a is equal to minus b, which is minus 1, plus or minus the square root of b squared minus 4ac over 2a. So it's 1 squared. So it's 1 squared minus 2 times minus 1. So it's minus 1 plus or minus the square root of 5 over 2 times 2, which is 4. That's what I get for a. All right, so now if a is these two values, you find the two roots. All right, you find the two roots and then you find them. So one of the root is going to be minus 1 plus root 5 over 4. And the other one is going to be minus 1 minus root 5 over 4. And one root is 1. So good. All right, so we can write it down that hence the x coordinates of the stationary points are, imagine they're giving away 11 marks for this. So easy. So find it there, x equal 1, comma, then you have x equal to minus 1 minus root 5 over 4, comma, and then you have, what's the next one? Minus 1 plus root 5 over 4. So these are the three x coordinates of the stationary point. Now they didn't ask us to find y, they only said x coordinates. All right, so now they said determine the nature of these stationary points. To determine their nature, you have to go back to the second derivative, which is this 36x squared minus 12x minus 12. So I'm just going to write down the second derivative up here again. So just to refresh our memory, f double prime of x is equal to 36x squared minus, it was minus 12x, I believe, minus 12x minus 12. This is 36x squared minus 12x minus 12. That's this, all right? That's the second derivative. So all we need to do now is find f double prime of 1. When we find f double prime of 1, what we're going to get is f double prime of 1, we have 36 times 1 square minus 12 times 1 minus 12. So f double prime of 1 is 12, which is greater than 0. And so we can conclude x equal 1 is a minimum point. X equal 1 is a minimum point. So this is a minimum point since the second derivative is greater than 0. Now do the same for here. So when x equal to minus 1 minus root 5 over 4, so f double prime of minus 1 minus root 5 over 4, find f double prime of this, and you're going to get that this is equal to, put it in the formula up here, minus root 1 minus root 5 divided by 4, and I have 36 times that square minus 12 times that minus 12. I get 21.2. I get 21.2. Which is greater than 0. Since it's greater than 0, this is also is a minimum point. So I can write, so up here, x equal that is a minimum point. And finally, going down here now, we have f double prime of minus 1 plus root 5 over 4 minus 1 plus root 5 over 4. Working out this, what we get is minus 1 plus root 5 divided by 4 is 0.3. 36 times that square minus 12 times that minus 12, that's negative 12. So in this case, we get negative 12, which is less than 0. And so this is a maximum point. So we can tell them that x equal minus 1 plus root 5 over 4 is a maximum point. Nice and easy, soft. The capital T. Nice. So this is a maximum point. Nice. Okay, that takes care of question 5. And now we move on to question 6, the final question on the paper. So looking at question 6, it says a function f is defined as f of x is x to the 4 minus 1 over x, and 4x and 2. Determine whether or not the limit of f exists when x is equal to 1. So we just need to show that the left-hand limit equals the right-hand limit. So first I'm going to work out the left-hand limit. So the limit as x approaches 1 from its left of f of x, it's going to be equal to, this means when x is less than 1, so use the top function. So that's going to be equal to the limit as x approaches 1 of x to the 4 minus 1 over x minus 1. So when we're doing this now, what this works out to be, it is equal to the limit as x approaches 1 of x to the 4 minus 1 over x minus 1. X to the 4 minus 1 can be broken up as x minus 1 times x cubed plus x squared plus x plus 1. And so now we have all of this is being divided by x minus 1. And so if all of this is divided by x minus 1, then x minus 1 cancels each other. Then you plug in 1 now and you get 1 cubed plus 1 squared plus 1, 1 cubed plus 1 squared plus 1 plus 1. And you add those 1 and you get 4. So that's the left-hand limit. So now let's check the limit on the right-hand side. So we need to evaluate the limit as x approaches 1 from the right. So checking the limit as x approaches 1 from the right, what we're going to be getting is, so plugging in on the right, it's the limit as x approaches 1 of 4 times x. So all you need to do is plug in x as 1 now. And so what you're going to get is 4. Now, since the left-hand limit and the right-hand limit are equal, then the limit exists. So, since the left-hand limit and the right-hand limit are equal, then the limit does indeed exist at x equal 1. So yes, the limit does exist. It says determine whether f is continuous as x equal 1. We can put a big dirty no. No, it is not continuous. And the reason is f of 1 is equal to 2, but the limit of f of x is equal to 4 as x approaches 1. And so the limit is not equal to its functional value. At x equal 1. So it's no. The limit is 4, but f of 1 is 2. So it is not continuous. Next part. It says the parametric equation of a curve is given by x equal 2 cos theta and y equal 3 minus sine theta. Determine the derivative of g of x. So there's 2 ways you can tackle this. There's 2 ways. First you could do is find g of x, right? Can I do it method? Yes, let's do it the 2 ways. I'm going to put a line right here, doing it 2 ways. Method 1 and method 2. Method 1. Method 1 is, what you could first do is you could say, well, x is cos 2 cos theta and y is 3 minus sine theta. So if you make sine theta and cos theta the subject from method 1, you would get that x over 2 is cos theta. X over 2 is cos theta, and you would be getting that sine theta is equal to, bring over sine theta, bring over y, 3 minus y. So 3 minus y is equal to sine theta. But remember, sine square plus cos square equal 1. So that implies that 3 minus y all square sine square plus cos square. Cos square would be x square over 4. And this is equal to 1. All we need to do is make y the subject here. By making y the subject, you can first expand this to get 9. All right, I don't need to do that. First thing you can do is to make y the subject, bring over this to get 3 minus y all square. So 3 minus y all square is equal to 1 minus x square over 4. You can then square root both sides. So I'm going to then square root both sides. When I square root both sides, this is what I get. And then I can, after I square root both sides, the square cancels the square root. And so then what I'm left back with is 3 minus y equal this. And so that means that y is equal to 3 minus the square root of, and instead of saying square root, I'm going to say y is equal to 3 minus 1 minus x squared over 4. Y is equal to all of this raised to the half power. Why did I put it to the half power? All you need to do now, this is now g of x. So this y is now g of x. So now you could find g prime of x. That's method 1. We're going to come back to this method. I'm just going to show you how we're going to get the same thing. And I'm going to put it in terms of theta because we know x as 2 cos theta. So we're going to come back to this. I'm just going to do it the parametric way now. The parametric way is to say that this is really, g of x is really y. So really what they're asking you to find is dy by dx. This is now method 2, which most people will do. Dy by dx is equal to dy by d theta, divided by dx d theta. This is dy by dx. And so what you're going to get is dy by d theta. Differentiate this with respect to theta. When you differentiate sine, you get cos. That's going to be minus cos theta divided by dx d theta. When you differentiate 2 cos theta, you get minus 2 sine theta. And cos over sine is cot, and the minus is cancelled, and so you get a half cot theta. So this is the answer, half cot theta. This is method 2. But what I want to show you is from right here, we're going to get the same answer. We're going to get the same answer. This is method 2. What I want you to do now, can I make a little bit more space? Differentiating this, you carry down the power to get a half. You subtract 1 from the power. So you're going to get 1 minus x squared over 4. And you subtract 1 from the power to get, minus a half minus 1 is minus a half times the derivative inside the bracket, and the derivative inside the bracket is times 2x, or rather times minus 2x over 4. That's g prime of x. And you might say, so how are you going to get it to look like this? Don't worry, that's the least. So I'm going to finish it off right here. I'm going to carry method 1 up here, the draw arrow. Just going to finish off method 1 in this small space. Now the minus, the 2 here cancels the 2 here. And so what you get is 1 over 4 minus 1 over 4x. So we get now that g prime is equal to minus 1 over 4 x times 1 minus x squared over 4, and all of this is being raised to the minus half. This is what you're getting for g prime. But remember, x is what? 2 cos theta. So x is 2 cos theta. So 2 cos theta over 4 is going to be minus cos theta over 2. We get minus cos theta over 2. And that is now being multiplied by, in this bracket here where you have x squared over 4, x square over 4 is going to be cos square theta, and 1 minus cos square, this is now 1 minus cos square. 1 minus cos square is sine square. So in here, so work out to be sine square theta one minus x squared over 4 is sine square theta, and it's sine square theta to the minus half, and sine square theta to the minus half, sine square theta to the minus half, that is just sine theta in the denominator. So all of this will work out. So you can finish it off and see it. But why do I have a positive here? This will be minus a half. Let's see something. dy is minus cos theta minus cancel. So where did I forget the minus? Oh yes, there should have been a minus here. Minus a half. And the minus will cancel each other. So get rid of this minus now. The minus them will cancel each other there. Minus cancel each other there. And this will give you the same answer as a half cot theta. No more space. Of course, I would have showed it a little better because we know that sine square theta to the minus half. This sine square theta to the minus half, you can rewrite it into the denominator as 2 sine theta. Sine square theta to the minus half going to come into the denominator as 2 sine theta here. Then cos theta over 2 sine theta is a half cot theta. So I'm saying you could have done it either way, method 1 or method 2, up to you. Method 2 is way shorter. It says determine the equation of the normal at this point. To find the equation of the normal, we use the point. We use y minus y value at the point, which is 5 over 3. And that's equal to gradient of the normal into x minus root 3. Before we can find gradient of the normal, we need to find gradient of the tangent. So we need to find gradient of the tangent first. So the gradient of the tangent is just going to be, now this is when x is root 3. This is when x is root 3. So the good thing is, you can find a gradient from this. Just plug in x as root 3 and get the gradient. Or if you want to use this formula, you need to find the value of theta that will give you x to be root 3. So from this here, x is 2 cos theta. X is 2 cos theta. So what's the value of theta to make x be root 3? All right, so x is 2 cos theta. Let's write it down around here. X is equal to 2 cos theta. So if x is equal to 2 cos theta, and in this case x is root 3, so we have root 3 is 2 cos theta. Root 3 is 2 cos theta, so we divide by 2, so that implies that theta must be equal to cos inverse of root 3 over 2, and all I did was divide both sides by 2 now. Divide both sides by 2, and that will give you cos theta is root 3 over 2. For cos theta to be root 3 over 2, theta must be, is that 60? Cos of 60? No, the cos of 30. So theta is pi by 6. So we're finding the gradient of the tangent when theta is pi by 6. So we're finding the gradient of the tangent when theta is pi by 6. Just want to let them know right there. So the gradient of the tangent is going to be, you plug in theta as pi by 6. In here, you're going to get, so the gradient of the tangent is the cos of pi by 6 divided by 2 times the sine of pi by 6. That will give you the gradient of the tangent. So the cos of pi by 6, cos of 30, cos of pi by 6, and we just found it. I don't know why I had to rewrite it, root 3 over 2. And that's being divided by the sine of pi by 6, which is the sine of 30 degrees is a half times 2 is 1. And so the gradient of the tangent is root 3 over 2. Now, since the gradient of the tangent is root 3 over 2, the gradient of the normal is now minus 2 over root 3. That's the gradient of the normal, minus 2 over root 3. Now that we get the gradient of the normal, we're fine. We're absolutely good. So now we can say, okay, the equation of the normal, I'm going to write this now. This is the normal. So the equation of the normal is given by y minus the y value. What was the y value? The y value was 5 over 2. So it's y minus 5 over 2. That's equal to the gradient of the normal, which is minus 2 over root 3 into x minus root 3. Now, I am not going to go any further. I'm going to stop right here. You could proceed and simplify. Make y the subject. So this is the normal. I'm not going any further. Nice and easy, soft. All right, now this says now, the slope of a tangent of the curve at any point is equal to the product of the x-coordinate and the reciprocal of the y-coordinate of the point of tangency. Formulate an appropriate differential equation. So this is differential equation. So let's read this question carefully. The slope of a tangent of a curve G. So if it's a curve G, then the slope of the tangent is G prime of x. So the slope of the tangent at any point, they're telling us that G prime of x is equal to the product of the x-coordinate and the reciprocal, the product, it's a product, product of the x-coordinate, so the product of the x-coordinate and the reciprocal of the y-coordinate. The reciprocal of y-coordinate is, so it's x times 1 over y. So that's the differential equation. G prime of x is x times 1 over y. If G prime of x is equal to x times 1 over y, then I'm going to rewrite G prime of x now as dy by dx. G prime of x is the same as the first derivative, dy by dx, and that's equal to x over y. So if this is what we have, we can go ahead and solve this differential equation by cross multiplying to get y dy is equal to x dx. And then once you get to this stage, you integrate both sides. And when you integrate both sides, the integral of y is ln y. I'm tripping. Integral of y is not no ln y. The integral of 1 over y is ln y. I'm so used to getting an ln differential equation. The integral of y is y squared. And that's equal to integral of x is x squared. And I forgot to divide by 2. Divide by 2 plus some constant c. I'm going to call it c1 for now because I'm not finished yet. Now I'm going to make y the subject by multiplying through by 2. Multiplying through by 2, I get y squared is equal to, multiply through by 2, I get x squared plus 2c1. And then I square root both sides now to get y is equal to the square root of x squared plus k. And you're going to ask me, sir, where that k come from? Where does k come from? K is just another constant where I let k, so you can tell them where k is equal to 2c1. K is equal to 2c1. That's all I did. Substitute a constant k for 2c1. Nice. Easy. Soft. It says hence or otherwise determine the equation of the curve given that it passes through 1, 3. So pretty much they're asking you to find the value for k. If it passes through 1, 3, then they're telling us that when y is 3, x is 1. So 3 is equal to the square root of x squared, which is 1 squared, plus k. So you square both sides first to get 9 is equal to 1 plus k. And then you subtract 1 from both sides. So you get k equal 8. And if k is equal to 8, then that just tells you that y is equal to the square root of x squared plus 8. This is the final answer. Y is the square root of x squared plus 8. And this concludes 2018 paper. Very easy, very fun. Perhaps the easiest Unit 1 paper you'll get. I hope it was just as much fun for you as it was for me. And so stay tuned. See you next time.